Elimination is an algebra method that we use to find the point of intersection of two straight lines. We have equation 1, x plus y equals 20, and equation 2, x minus y equals 8. This is a very simple example that makes it easy to see how elimination works. The thing that makes elimination work is the fact that we can add equations. It seems like a strange thing to do, but we can add these two equations together. We add the x's, we add the y's, and we add the numbers. X plus x is 2x. Y plus negative y cancels. There's no y in the answer. And 20 plus 8 is 28. The result of this is that instead of having two equations with two variables, we have a single equation with a single variable. And in fact, it's a very small equation, and it doesn't take very long at all to solve it. Since x is being multiplied by a 2, I will divide both sides by 2. These cancel, and x is equal to 14. To find what y is equal to, I plug x equals 14 into either of the original equations. Let's try equation 1. We have x plus y equals 20. If I replace the x with a 14, we have 14 plus y equals 20. Doing algebra, y is equal to 20 minus 14. Y is equal to 6. The answer for this system of equations, the point of intersection of these two lines, is going to be 14, 6. Adding two equations together is what makes elimination work. But it will only work if one of the variables, in this case the y, has equal and opposite numerical coefficients. Positive y plus negative y cancels to 0. That gets rid of the y, leaving us with an equation with only x, and that we can solve. But what do we do if we don't have a variable in the equations that has equal and opposite numerical coefficients? Here's an example. 2x plus 3y equals 28. 3x plus y equals 21. 2 and 3 are not equal and opposite. And 3 and 1 are also not equal and opposite. What we can do is we can take advantage of a rule of algebra that says we can multiply a term in an equation by a number, any number we want, so long as we multiply every term in that equation by the same number. By doing that, what we're doing is we are creating an equivalent equation, another equation that looks different but really graphs to the same line. In this case, if we multiply this second equation by negative 3, we will get negative 9x minus 3y equals negative 63. Now we have a negative 3y here, which is equal and opposite to this positive 3y in the first equation. So we don't have to change the first equation at all. And I like to show that by saying times 1. This equation times 1 is still equal to the same thing. It's still equal to 2x plus 3y equals 28. Now, working with this new version of our equations, we can do the addition step that we learned before. If we add these, 2x plus negative 9x is equal to negative 7x. 3y plus negative 3y cancels. We've gotten rid of our y's. And 28 plus negative 63 is equal to negative 35. Now we have that single equation with a single variable that is so easy to solve. If we divide both sides of this by negative 7, these cancel, our x is isolated, and negative 35 divided by negative 7 is positive 5. Now, to find the y in our point of intersection, we just have to plug x equals 5 into one of the original equations. I'm going to use equation 2. 3x plus y equals 21. If x equals 5, 3 times 5 plus y equals 21. 15 plus y equals 21. Y is equal to 21 minus 15. Y is equal to 6. We have our answer. The point of intersection of these two straight lines is going to be 5, 6. So when we're doing elimination through addition, if we haven't gotten lucky and gotten an equal and opposite situation with one of our variables, we can create it by choosing a number that we multiply one of the equations by, which results in an equal and opposite situation, and then we proceed with our method.